In this lesson, we're going to have an introduction to the Cartesian coordinate system, which you might know by different names, um, but it's named after René Descartes. I should probably have an accent on that name, 1596 to 1650, and if you want to look him up, he was a philosopher, mathematician, had a lot to contribute to the development of mathematics, and the Cartesian plane or the Cartesian coordinate system is named for him. So there's actually kind of a neat story. It may be myth, maybe fact about him lying in bed and looking at the fly spots on the ceiling and how he came up with the plan for this system. And what he realized was that any point on a two-dimensional plane could be indicated by an ordered pair. And so we call the ordered pairs x and y. This is the x axis is the horizontal axis or the independent variable when you're comparing two different variables. And the vertical axis is called the y-axis. The Cartesian, so the x's, the midpoint here where they cross at 0, 0 is called the origin. So the point 0, 0 is called the origin. And the whole system here is split into 4 quadrants, and we use Roman numerals to indicate them. So quadrant 1, quadrant 2, quadrant 3, and quadrant 4. And when we use points or ordered pairs to indicate points, the first one is always the x or the horizontal axis, and the second one is always our vertical one. So if I have the point A, 5, negative 3, I'm going 5 to the right and 3 down to get the point A, and B, 2, 2 will be over 2, up 2. And I apologize, the pen is not going exactly on the spot because I need to reorient the smartboard here. And point C, I have the coordinates negative 6, negative 3. So that means I'm going 6 to the left and 3 down. So 2, 4, 6, 1, 2, 3. And there's point C. Okay, so it's always over and then up or down to plot points on the XY grid or the Cartesian plane or the Cartesian coordinate system. So when it comes to graphing equations, an equation is often used to express a relationship between two quantities or two variables. And then we call the solution to the equation is the set of all the ordered pairs that make the equation true. So if I have as an example y equals 6 minus x squared as my equation, it shows the relationship between x and y. I can create a table of values, and I'll just choose some values for x. So negative 3, negative 2, negative 1, 0, 1, 2, and 3. And I'll substitute those values of x into the equation and to calculate what y is. So when I square negative 3, I get 9. 6 minus 9 is negative 3. When I square negative 2, I get 4. 6 minus 4 gives me 2, etc. So I'm going to just fill in the rest of these values here and plot these points. So now this point has coordinates negative 3, negative 3, etc. And this one is the point 2, 2. So I'm going to plot those 7 points. Negative 2, positive 2. And because I know it's symmetrical, the last ones are much easier to plot. And I can just, because of the nature of this one, I can join it with a curve. And I can see that if I were to extend my x values in the other directions, my y would continue to go down. So I could put arrows on the curve when I'm finished. And I'll label my x and y axes, and I'm finished. So this curve shows the solution to that equation because it's all of the ordered pairs that make that equation true. Let's do one more example. If you have the example y equals the absolute value of x plus 2, we can again set up a table of values where we're choosing values for x. And again, let's go from -3 to +3. And let's calculate what our y values will be. So the absolute value of -3 is 3 plus 2 gives me 5. The absolute value of -2 is +2 plus 2 gives me 4, and etc. So I can continue doing this, 3, 4, and 5. Okay, so now I've got these ordered pairs, so I can plot them to figure out what this relationship looks like. So the point -3, 5, -2, 4, -1, 3, 0, 2, and then I go 3, 4, 5 again. Okay, so this one consists of straight lines, and this would be really good to do with the straight edge. Harder to do that on the smart board. You use the straight edge to sketch that. So you can see that we've got two straight lines, sort of a V-shaped relationship here, and it's actually called an absolute value function, which we will get into in the next couple of days, more of what those look like. We're also going to look at using technology or the graphing calculators to sketch graphs, and we'll do that together in class. Using the class calculators or your apps for the graphing calculators. And we'll also look at the idea of what a viewing rectangle is. And in the Texas Instrument types of calculators, that's using the window or zoom features so that we can adjust how we see the graphs. And we'll practice that together in class. The last thing I want to look at for this short introduction is what an intercept is. An intercept is really where the graph crosses the axis. So if you look at the graph of y equals 6 minus x squared, you can see that the y-intercept happened at 6. Okay, the graph crossed the y-axis at y equals 6. And the x-intercept is approximately, there's one at -2.4 and there's another one at approximately +2.4 along the x-axis. So there's two x-intercepts. So you can think of the x and y-intercepts as just a single number. But the other way to look at them is an ordered pair. If you think of what the coordinates of the y-intercept are, the coordinates are actually 0, 6, because x is 0 when y is 6. And the other coordinates will be -2.4 and 0 and +2.4 and 0. Okay, so you can think of the intercepts as ordered pairs or as single numbers. When you see it as an ordered pair, it helps you to realize that your y-intercept occurs when x is equal to 0, and your x-intercept occurs when y is equal to 0. Okay? And again, we'll look at using technology along with these basic skills of Cartesian coordinate system graphing.